So number one, what'd y'all get? 311 Kelvin is correct. Everybody got their homework before I keep going? 311K.
Are you going to post this on the website?
No. I mean, the answers are being called out.
I don't have my.
Please pardon the interruption. Teachers, would you please release the students that were sending your email going on the field trip to see the Crucible play at Wake Forest University? Thank you.
All right, Allie, did you see what I did?
Yes, I did.
Okay. That's the best I can do for you. All right, number two. I was trying to be helpful. Number two, negative 148 degrees C. Who left? Aren't you going? Michaela?
No.
Oh, I thought you were. So I was like, why are you leaving all that crap on my desk?
When you write in Kelvin, you don't need a degree.
No, Kelvin does not have a degree. It just has a K.
Can I move?
You can move anywhere you want to.
Oh, God. I thought you were going.
I'm going to, but I'm not trying to fix this class hand. Because that's
So many options.
Too much.
Just park it.
I know.
All right, so negative 148 degrees C. What'd you get for number three? Yep, 1.25 liters. What'd you get for four? 0.0418. All right, you rounded up. That's fine. I would have just left it at 0.04175 liters, but it's fine if you rounded it up. It's not a problem. All right, number five.
Number 5.
0.696.
Say what?
0.1696.
Yep, 0.169 moles. You could have taken that a little further like Elijah did. It's fine, but decibel 169 moles. What'd you get for six?
15.2.
Yep, 15.2 grams. All right, seven.
Oh, I
Yeah, don't even know. Anybody?
don't know. I think I did it wrong.
16,328.125.
Okay. How about we put it in scientific notation? That's gigantic. Yes, it was still right. But guys, when you get a number that's greater than 1,000, put it in scientific notation. You should change that to 6.33 times 10 to the fourth PA.
It should look like 4.75 and then 1.1 and on the bottom of it has 760.
You got 760 on the bottom, and then you have 1.01325 times 10 to the fifth on the top. All right. What'd you get for eight?
Not a right answer.
935 Tor?
Hey, really?
935 Tor.
Yeah.
All right. 9. Want to be brave since you said you got 8 right? Zaya, what'd you get? Yeah, you. You just didn't. I'm asking for 9. How about 9? No. How about 389 Tor or KPA? All right. And number 10, 1.69 times 10 to the fourth PA. Or 16,900 and something, something, something.
So you said,
I did almost. Yeah.
but what's in scientific notation?
1.69 times 10 to the fourth.
Out of the 7 to 10, I only got number 8 right.
So in number 7, I'll go be a deep doo-doo on these word problems if you don't fix these. All right, 475 millimeters of mercury. Millimeters of mercury, and you're going to Pascal. All right, what's the number on the top of the chart? Because I already put them on here too, for millimeters of mercury.
760.
So you're putting 760 beside millimeters of mercury. What's the number you have to learn for pascals?
The 1.1325
Times 10 to the fifth. Now, can we still use that number in the calculator?
Yeah.
Okay. So
I mean, I get why I did it wrong now. It's just, I feel like I was looking back on the notes and we did something weird. It was like, I don't know. I don't know.
So you would say 475 times 1.01325 second EE 5 and divide 760. So if we're Elijah and some of the rest of you, now that's the answer he called out. Now, do you remember what I told you yesterday about I wouldn't take off for significant digits provided you were within one? And he read me that whole number off the calculator.
Wrong.
How many is there?
3.
As long as you're within 1 or 2, I'm okay. You write all that down. I'm taking off for significant digits. Okay? You had 3. So if you had written this, I'd have adjusted. Okay? You write down every number on the calculator, I'm taking points off. Okay? Secondly, this is 63,000 something. How about you put this in scientific notation? You can use mode on the calculator if you can't move the decimal. That's completely cool. Okay? So 6.33 times 10 to the 4th PA. Okay? Because you use a calculator wrong. Let me see.
Oh.
I changed the mode until I got the 6.
Oh. Sometimes it does that when you go to mode. Just punch it in again. Sometimes it doesn't. Sometimes it does. I do not know the rhyme or reason for why it does it, Xavier.
Where did you go if we're not going to
Or regular classes.
Class.
Where else would we go?
They have a sub, I'm sure, up
Yeah,
there.
we have a.
Right here.
There's no such thing as subs.
But I think.
Yeah, there are. They're just hard to come by. I've seen Mr. Lewis, I've seen Miss Poe, and there was another lady I saw that I know the name of.
I just bad.
If you need to. You have any hall passes left, or will I be adding you to my detention list? You have one more.
What are we?
How many do we have?
3?
They're not 3 per.
No. Whole semester. All right, so any other questions we need to work for the homework on how to convert? Put it around your neck. Which one? 10? All right, so 10 has 127 torr. And you're going to PA. So torr goes on the bottom, PA goes on the top. So what number goes beside torr, Sam? Beside torr?
Oh, 760.
Yeah. All right, and now beside PA.
1.015.
Okay, so now can you punch that in the calculator? Because you gave me the right step, so I'm guessing it's a calculator error. Oh, well, that'll do it. All right,
I
so
messed up because I put, instead of like both of those numbers, I put 1 on next to the PA, I guess would be, and then I put what PA's thing was because they all equal 1 atmosphere. I just thought.
yeah, no, you only put 1 if it actually has atmospheres in the question. So like if you had a chart set up and it had ATM in the chart, let's just say you were going from 425 millimeters of mercury, okay? And you had millimeters of mercury here, and you had ATM in the chart. If ATM is in the chart, you use the 1 and then 760 next to millimeters of mercury. But if there's no ATM in the chart, you won't use 1. Does that make sense?
Yeah.
Okay. Sam, did you get it? Okay. So you just didn't have a calculator last night? Okay. Exponents are hard to do if you don't have a calculator.
No, this is app. That's just like that.
Yeah, the we shall be. I need to download it.
Okay. I think it's easier to do on an Android phone than an iPhone, but a lot of people are pretty proficient on an iPhone. I'm just not one of them. All right.
What was the answer to that?
Miss Well, I thought you have an iPhone.
I do. I just don't do the calculator app very well on the iPhone.
You have 2 phones?
No, I just know that people who, they let me use their Android phone with the traditional TI whatever calculator app. I think it's easier to use on the Droid. 9 was 389.
Oh, I got that one.
All right. Any other questions on the homework? So I feel okay about converting. Princess is just staring at me. You okay on those? Did you try any of them? You weren't here yesterday? You want homework paper? Did you watch the video? Catch up on anything? You gonna catch up on anything? She's thinking about it. She's like, no.
We have stuff included with temperature and stuff.
Yes, and I will change the units on stuff on the quiz. So you're gonna have to convert on the quiz. Okay?
It's so quick. Why you get so quick?
The Jets on.
Where can you play out? You can try out? You can try out?
Basketball?
Yeah.
No, that's what.
I
was funny. I don't know what to do. I was like, I was like,
Oh.
asking Lana, she was like, oh my god, I can't believe
Just
you're.
are you?
Oh yeah, she was there.
Is he good?
No, I'm not good. No. It was my first day.
Okay.
It was my first day, but I was there.
leave for doing bad.
All right, so yesterday we did Boyles law, right? I drew some really ugly boxes. We talked about what happened with pressure and temperature. All right, because you don't have to write this, you already have it in your notes. All right, we talked about pressure and volume at constant temperature and moles, right? So I drew some ugly boxes. What was the relationship we had said it was yesterday? What happened to? All right, so pressure and volume are inversely proportional. So what did it mean when we said they were inversely proportional?
One goes up, the other goes down.
One goes up, the other goes down. So as we made the volume smaller yesterday in our box, what happened to the pressure?
Smaller, bigger, up.
The pressure went up, okay? So pressure was created when the particles hit each other in the container walls more often, right?
Yeah.
So as we made the space smaller, the particles hit the container walls of each other more often. Sort of like at the moment, if I took all of y'all and I shoved you in the stock room right now and I made you move around, what are y'all going to do to each other more often? You're going to bump into each other, particularly given that Miss Rector has a giant pallet of cookies sitting back there for the barbecue chicken dinner. You can't have them, Franco. They're locked up, okay?
Are they still the raisin ones?
I don't know what kind they are.
For some reason, some chocolate.
Really?
I never
I need to make sure I get chocolate.
Right, they always give out raisins.
I don't want raisins. I only want chocolate. All right? I know it's random.
You take what you get.
I don't want to take what I get. I got to talk to her about that. All right, so P1 V1 equals P2 V2. All right, was the formula I gave y'all, right?
Yes.
All right, so now we need to talk about how to work the problems. Now, the nice thing about the formulas, that's not a problem. The nice thing about the formulas we're working today is all four formulas, even though they're different, they all work the exact same way. So once you learn how to work one, you should know how to work them all. Okay? The bad part is, for those of you who struggle with math, if you don't get one, it's hard to get all of them. All right? But those of you who are very math-minded, once you get one, you get them all. So I'll give you a minute to write that down. I would recommend you write down one for each problem so you have something to refer to. Okay?
The whole thing?
The whole thing. There's really no way to make it shorter.
Well, you watch Vsauce?
You all watch what?
Vsauce?
No.
I feel like you would. I feel like you would like this.
I don't watch a lot of TV.
He's
Did you? Okay.
Vsauce.
What is the other thing? ASAP sign. I don't know. Maybe it isn't that bad. Right.
It was one with the Marcus Epstein stuff. They were both cute.
Sometimes they come back and be like, we were wrong. So it's just like,
Really?
yeah.
I forgot about Marcus Epstein.
What do you like doing in your spare time?
Same thing I'm doing right now, which is what? I was reading my book.
Do you like reading?
Mhm.
What kind of books?
Generally happy ending books.
You don't get a lot of those now. Everybody's trying to be anxious. Like, usually you have the ending, so we're going to give you a sad one. But
No, I don't read those.
now.
I read the ending of the book.
know?
I read the ending of the book first. If I don't like the
Oh my
ending, I'll read the book.
Wow. That takes all the fun out of it.
No, it doesn't.
For English, we had to read.
I've only met one other person like me, but I've met another person who does that too, so I don't feel too stressed.
Yeah, some people read the book backwards.
Do you do
No,
that
I don't
with
read it
movies?
backwards. I just read the last chapter. So if I don't like the way the book ends, I'll read the book.
Do you do that with movies too?
I don't watch a lot of movies.
You don't learn any character development that way. Like, what if it was good, but the ending was just garbage?
Yeah, trash.
But the book would have been so good, you would have read it from the beginning.
Doesn't matter.
Nah.
Doesn't matter. If it's a terrible ending, I'm not reading it.
Well, there's multiple books.
I mean, I'm not into literary books that are, going to be fabulous and on the bestseller list because they're just that great.
I know, but what if it was like
I'm
a
so
book, like a low-rated book, but like the good guy turned to the bad guy, but you knew he was a good guy, and then he like died at the end. You're like,
Oh, if he died at the end, I'm not reading
and
it.
you're like, oh my god,
The dog dies, the main character dies. No. I'm not reading those.
What if the main character was like a serial killer, but you thought he was good?
Plot twist.
Forget that. It's not my thing. All right. So if we look at the problem, first of all, how are you going to know that this is Boyle's law? You're going to have 5 laws we'll do 4 today, 1 at the beginning of class tomorrow, so that we'll have 5 laws on the quiz Friday. What will tell you that this is Boyle's law when they're all mixed up?
Temperature remains constant.
All right. So temperature remains constant right here is what tells you is Boyle's law. Okay? Now, you don't have to be able to tell me this Boyle's law until the test. All right? But it also tells you that you want P1 V1 equals P2 V2 because what is not in this formula? What variable is not in that formula?
Temperature.
Temperature, okay? Because temperature remains constant. That means temperature's not changing. They didn't give you a temperature anywhere in the word problem, did they? So that's what tells you to pick a formula that doesn't have a temperature. Now, don't write this down. All right, in a few minutes, we're going to work a formula that is this one. Okay? You have to have a temperature to use this formula, right? Do you have a temperature anywhere in this word problem? Did they give you a Celsius or a Kelvin anywhere in the question? No. So you couldn't use this formula because you don't have a temperature anywhere in the formula, right? Now, so we know we're going to want to use that one. But if, let's say, I'm sitting there and I'm like, I just don't know what formula to use, Ms. Wall. Take a step back and let's identify what we know. All right, so this is why I've pushed units all semester long. What is this? It's a milliliter. What's a milliliter? Is it a pressure, a volume, or a temperature?
Pressure.
Volume.
Milliliters is a volume. Okay, that's a volume. So I'm going to say volume is 150 milliliters. Now, do you see how it says when its pressure is 720 millimeters of mercury? Now, I happen to say its pressure is to tell you that 720 millimeters of mercury is pressure. Sometimes it will state that, sometimes it won't. So, millimeters of mercury is a pressure unit. You have to recognize that. Now, I point out that see how the wording says 150 milliliters when its pressure is 720? Those two numbers are a couple or a pair. That 150 has to stay with that 720. You see how it's worded that way? Like in English class, when its pressure is. So you can either make these V1 and P1, or you can make them V2 and P2, but those two numbers have to stay together. I make them V1 and P1 because I read them where in the problem? First. All right, when I keep reading, it says what volume. So that means I'm looking for volume. And then I find 750 millimeters of mercury. And 750 millimeters of mercury is a what?
Pressure.
It's a pressure. Now, if I do that first, sometimes it's easier for students to go, oh, I don't have a temperature, so I know my formula has to be what then? Then I can figure out my formula is V1, P1 equals V2, P2.
Is that saying they're multiplied or
What?
like the V1 and P1?
They're multiplied. So if you look, half the time I flip the way they're written because I can never remember the order, so I flip them back and forth half the time. It doesn't matter the order. Now, to use the formula, there's one rule and only one rule. All right? The units must match. It's the only rule. So when you check, do your units match? Are they both millimeters of mercury?
Yeah.
Yes. So that means when you solve, your volumes are going to come out in what unit? Milliliters. Okay? So when we plug in, V1 is what? 150. P1 is 720 equals, we don't know V2. P2 is what? 750. Now, you will never see me pick up a calculator at this point. I will not pick up the calculator until I've solved. So how do I get V2 by itself?
Divide.
Divide by what?
720.
Divide by 750.
That's what I meant. Oh my God.
And then divide by 750. So when we solve for V2, 150 times 720 divide 750. So I get 144.
I'm getting the exponent. Is this yours, Xavier?
Yes.
Oh.
All right, so 144. And again, the units have to match. So when I look, this was what?
Milliliters.
So that means I have to get
Milliliters.
milliliters for my answer. Does that make sense? Yes? No?
Yeah.
Okay.
Easy. So it's like.
All right, you think you can try one?
Yes.
All right. Now, this one has a slight difference. You don't have to write it down. Just solve. You have a sample in your notes. So find me the answer.
Who wrote the question?
I wouldn't. You already have a sample, so I wouldn't write it.
Altitude is the same as volume. Altitude and volume are the same.
No.
So what do I do?
You need altitude.
I need volume.
Okay. You don't need altitude.
So is that? Oh, so that's just like something through in there just because.
Yep.
I hate that. Well, depends on who that is.
What is this? It's okay.
Okay, so I'm gonna have to convert this.
You are fixing to have to convert this.
To atmosphere or to tour?
Either one, you choose.
Does it matter which one? I
No,
pick?
it doesn't.
I'm just taking this. Can you bring me one? Please.
There's one right in front of me.
That's bigger. This is a weird explanation.
Do you need one, princess?
I could just easily turn it into tour by just doing 1 times 760. Should I do that?
Sure.
Alright.
I'm say I have no dog in the fight. You do whichever one you want.
I'll give us a beach here.
Huh?
I'll give us a beach here.
Me too.
I don't really do that. Yeah, I know.
No, the next year was on, I think.
It was near and me. You went up there.
It was Lozano's one though.
I know I saw him being up there,
Not for me. I like her house.
but I felt bad afterwards with that time.
Yeah, I didn't like her either, but I didn't want to lock her out like that. That's so rude.
I wish he shoved Peggy now.
Huh?
I wish he shoved Peggy.
She was.
Shoved Peggy.
Everyone said my brother told me that he broke her butt. She like fell and like this dude like broke her like that. Now she doesn't get it. When Chris was in the class.
Is that an answer? I don't think it's right.
All right, we got it?
You know, I think I'm here.
It's right as well.
Bless you.
Thank you. You know when you can feel a sneeze and you redirect it instead of coming out your nose, as well as a cough?
Yeah.
You know?
What?
Like you redirect your sneeze instead of a nosy sneeze.
Oh,
you
yeah,
know,
yeah,
like,
yeah.
you do like that.
All right, so is everybody okay with what Michaela said in that 6.5 kilometers? We don't need that. So we just sort of chuck it because we don't care how high the balloon went. That's irrelevant information, right? Yes? Sam, you're just sort of staring at me. Are you with me? Or you've left the planet? Okay. You do understand the 6.5 kilometers jump. Okay.
Can we get a decimal? Can we rather?
Yeah.
Yeah, I got it.
Okay. So it tells us we have a volume of 500, right? So I'm just going to make that V1 because it says we have a volume. All right. At a pressure of 1. So those two things have to stay together, right? So volume is 500. Pressure is 1 atm. Okay? I don't care what the altitude is. It's irrelevant. All right? After the balloon is released, it gets to a pressure of 450 torr. And it wants to know, assuming the temperature remains constant, what is the volume? Okay? Now, this one is different than the last one. And I'm going to change the orientation here so I've got more space. It's not teeny tiny. All right? This one is different than the last one because what can you tell me about the pressure units? They're different. They have to do what? They have to be the same. They have to match. So, you can either make both of them ATMs or you can make both of them what?
Or
You choose. Okay? Doesn't matter to me. Now, if you listen to Michaela a minute ago, she was like, oh, 1 ATM is equal to 760 torr. So that would have saved you converting. But if you didn't do that, it's completely cool. 450 torr. What goes on the bottom? That's there. So we're going to put torr to ATM. What goes beside ATM?
1,
Beside torr.
768.
So 450 divide 760 is 0.592. Okay? So 0.592 ATM. Okay? So you choose. Do you want to use the ATMs or do you want to use the torr? Doesn't matter to me. I could care less. So,
Will you get the same answer either way?
yes, you'll get the same answer either way. All right, so P1 V1 equals P2 V2. So my pressure 1 is what? I said pressure 1. Okay, so if you did the torr, you'd have 760. Volume 1 is?
500.
Okay. So when you pick pressure 2, because you use the torr, you have to use the torr. So you'd have 450 times volume 2. And I'm going to leave a little space. Okay, we'll come back and solve that one in just a second. Now, if you were the group that did ATMs, for your pressure 1, you would have had, I'm going to change colors for that one. Okay, if you did ATMs, your pressure would have been 1. Your volume would be 500. Your pressure 2 would be the 0.592. And you'd have found V2. Okay, so this is the torr way. And this is the ATM way. Okay, works the same way. So if you're the torr people and you did it this way, what do you divide by to get V2? You divide by what?
450.
You divide by 450 and you'll get V2. So we would take 760 times 500 divide 450 and we get 844. And the units have to match, so it has to be milliliters. Now, if we're the ATM people, we have to divide by 0.592.
Oh.
And I get 844.
I can carry mine out to the 9.2. That's the 0.59, and I got 847.
It's fine. Your work would suffice, so it would be fine. Anybody else? Question?
That's water.
Sure.
Yeah.
Everybody okay with having to convert? Does that help, Sam?
Can I get some lotion from Miss Wicker?
I got lotion in my drawer. It's
I
just,
asked you yesterday and you said no.
it just smells like sweet pea. I don't like the scent, but it works.
Sweet pea. What is sweet pea?
Some stupid scent somebody gave me for Christmas one year I don't like. All right, Charles' Law.
That's my name.
Charles' Law is volume and temperature at constant pressure. All right, so we have an ugly box again with a pickle for a thermometer.
I
Yeah,
think you're talking huff it.
and get it off the lid.
My bad.
Wait, I want to smell it this time.
They want to smell the goodies.
Yeah.
All right, so some molecules in there. All right. I guess I'll make our thermometer blue since I drew the box in red. All right.
like
Are you okay over there?
Me? Yeah, no, yeah.
All right.
yeah, no, or yeah. Oh, my God.
All right. If we increase the temperature, what's going to happen to the particles inside that box?
They're going to get big.
No, move
They're
around.
not going to get big.
Move around.
All right.
Same thing.
No.
All right. They move more. When they move more, what do they do more often?
Touch
Touch.
Touch what?
each other.
And the
And the.
Container.
All right. They move more and collide more often with each other and the container walls. Now, if they collide more often with each other and the container walls, what is that going to do? Cause what to go up? What?
Pressure.
All right. Pressure will increase. But we want pressure to remain constant. So, how can volume be changed so pressure will remain constant?
Wouldn't say if there's a party cut off.
All right, so based on what we did yesterday, we know that if we increase the temperatures, the particles move faster, right? So if they move faster, they have to collide more often. Is everybody with me on that? That's going to make the pressure go up. But Charles' law says pressure is constant. So do we want the pressure to go up? No, we want the pressure to stay constant. So what can we do to the volume so the pressure will remain constant?
Increase it.
All right, Elijah says increase. Do we agree or disagree? What do you think, Janai? Oh, I get a shrug. Huh? All right, if we decrease the volume, all right, if I put y'all all in a small space, are y'all going to hit more often or less often? More often. Will that cause the pressure to go up or down? It causes it to go up, right? We want the pressure to stay constant, so we don't want y'all to be closer together. So if we increase the space, y'all will collide less often. Does that make sense? So we want to increase the volume.
But when to decrease the pressure, not keep it up.
Well, the idea is if you give it more space, if you increase the temperature, you have to give it more space to account for that increase of temperature. Okay? So anytime you increase the temperature, you got to increase the volume also to try to balance out the pressure. Okay? That's how you keep it at a constant pressure. So we will increase the volume so pressure can remain constant. Okay? We're going to increase the volume so pressure can remain constant. All right, everybody caught up?
No.
Now, if I circle what we said, all right, Pressure is constant. So we increase the what? We increase the what?
Temperature.
And what do we do to volume?
Increase the volume.
All right. So what relationship is that?
Proportion.
Directly proportional. I'll go back. I just need to see if I had space on the next page to write. Princess, you got your Crocs all right?
Wow.
All right, everybody caught up? Who said no? Franco, what in the world? Oh, that's right, you were slathering lotion on.
I'm almost caught up.
You need to go faster. It's so warm in here, I'm gonna need to take a nap. All right, so the formula for this, well, let's write the law down. All right, volume and Kelvin temperature. Notice I said Kelvin temperature at constant pressure, and in parentheses again, I'm gonna write and moles, are directly proportional. All right, so this formula is V1 over T1 equals V2 over T2. Yes, and moles. Okay, because remember, we're doing all the laws that have no moles and no grams first. So there will be no moles in anything we do today and early tomorrow. We won't pick that up until late tomorrow at the earliest, and then on Friday. Now, just like the last law, all right, with Boyles' law, there was no temperature, right? So what was not in the formula? There's no temperature in the formula, right? So with Charles' law, what's constant?
P.
So what's not in the formula?
Pressure.
There's no pressure in the formula. See that tie-in, that correlation? Everybody with me on that? Okay, I know some of you are. The rest of you just stand there staring at me. Or you're writing feverishly.
Thank you.
All right, we caught up? I can see Princess is still writing.
Who painted that kid?
I did.
You painted all of these?
Yes.
You painted? That's cool.
Now,
I like it.
try the sample now.
What is that? Wait, all of it?
No, right half.
Yeah.
Right all of it, Sam. Come on.
I don't even know why you joked around her.
After a whole, 12 weeks? I don't even know what week we're on. We're on day 50 something, 54? No, we're higher than that. 57?
Really?
It's been a long.
57? Why would I want y'all to write only half of a sample problem?
That'd be cool.
Just write the first students and see what happens. Are you done having children?
Me? Yes.
Yeah, she talks bad about her children every day.
She doesn't coach bad enough every day. I don't think bad is the right word.
Yeah, it's gonna kind of be tough.
Do they watch your, do you know you have a class video?
Yeah, they know how to class video. They're not shocked that I would talk bad about them.
It's just tough love. Or just tough.
I think it's just funny and they know it.
Yep.
Yeah.
They would probably both prefer I never mention it ever, but, you know, that's never gonna happen.
Even good things?
Yeah, probably so.
Yeah, I've heard you say good things about your children.
I feel like I have. No, one of them's like really smart. Another one plays sport.
Whether it's in a band.
And what, the youngest one's in the band, although he hates it, absolutely hates it.
Why? Why do you see it?
Huh?
Why do you see it?
Cause I made him.
Why did you see it?
Well, the band teacher taught him into doing band, and then he left and went to Central Davidson, and so he has a first-year band teacher, and so he's pissed because the band teacher who taught him into taking band left. So he doesn't like the band teacher.
Oh.
And the class he really wanted out of, which was theater, because you know as a freshman at West, all the seniors get scheduled first, and all the juniors, then the sophomores, then the seniors. It works a lot like colleges do. Yeah, theater. And he really wanted out of theater. Turns out he likes theater better than almost all of his other classes. So,
Why are all our classes like regular? Like,
I mean, his schedule is band, PE, math 2 honors, and theater.
that's
I mean, what more does he want as a freshman? He has virtually no homework any night during his first semester of a freshman year. Give me a break. Yeah, Shelby, her first semester of freshman year, she did cross country. She had 3 nights of dance. She had honors math 2, honors biology, honors English 9, and I think a computer class. So she had one class that didn't have homework every single night. She was up to midnight almost every night for homework.
Oh.
I wish my parents told me. I know, right?
So, I mean, it took her weeks to figure out how to survive freshman year.
How old is your oldest child?
She's a senior. Huh?
She did that freshman year?
Oh, yeah. I mean, she's done dance since she was 3. So, she does competition dance and she did cross country. And she stuck that out for 2 years, but she finally decided she couldn't manage cross country and 3 nights of dance. Plus, when she got into AP classes, she was like, something's got to give. So she dropped the cross country. All right, so when we look at this question, how do you know this is going to be not a Boyles Law question? Just to show that it's different from what you just did. All right, it has temperature. And what else does it tell you?
Volume. Wait, no, never mind. Pressure.
Constant.
Okay, see how it says pressure remains constant?
Wait.
That's going to rule out Boyles Law.
Volume
Okay.
and temperature is what we do have.
Okay, so remember the law we just did?
Yeah.
See how it says pressure remains constant?
Yeah.
That tells you can't use that. Okay, because you got to have a pressure to plug in to use that formula. Does that make sense? And because it says pressure remains constant, you can't use it. Now, will it always say pressure remains constant or temperature remains constant? No, if it doesn't include it at all, what do you assume? That it's constant. All right, so what is this?
Charles' law. Wait, what?
Is it a volume, a temperature, or pressure?
Volume.
So it's a volume. All right, see how it says at 25? What is 25? Volume, and temperature, or pressure?
Temperature.
Okay, so it's a temperature.
I thought it had to be Kelvin.
Getting there.
Oh, so it does have to be.
Yes. Now, because it says 752 at 25, these two numbers, again, have to stay together. I made them the ones because they were where in the question. At the beginning, you could just as easily have made them V2 and T2 if it made you happy. Now, if we keep reading, it says what volume? So we're solving for volume. At what temperature?
50.
Now, if you were listening to Michaela, She remembered what I wrote down because she said, whoa, where's the Kelvin at? Here's the catch to temperature. Every single time you use temperature, it's not only that the units must match, temperature has to be in kelvins. They not only have to match, they have to be in kelvins. Okay? Every single time. So you have to take that 25 and you have to say 25 plus what? 273. People, the formula's on your reference table. If you don't know, you can look it up. Okay? Hopefully after we do this today, it'll be firmly planted in our brain. But if you look at the formula page of your orange staple sheets, on the formula page, about, I don't know, midway down, it says K equals C plus 273. All right, you can look it up if you have a moment and you forget it. Page 3 has the formulas. You can just look it up. So 25 plus 273 is 298K. All right, 50 plus 273 should be 323K. I'm doing the math right in my head.
You're so smart.
Okay, so you're going to get rid of those two. We have to use the kelvins. Everybody with me on that? We don't have to worry about volume. The units have to match, so my answer will turn out to be in milliliters. All right, so from there,
Do the thing.
do the thing. So I need to plug and chug.
What?
We've already done the chemistry. All you have left to do is plug in the numbers and chug out the answers. So V1 is 752 over T1, which is 298, equals V2, which is 323.
You multiply by the denominator.
Now, you can do it any way you want. I will never solve it that way. Okay? If you've got fabulous math skills, do whatever you want, Michaela. A lot of us don't have fabulous math skills. All right? So, Ms. Wall only solves it by cross multiplication. All right? Some of y'all suck at fractions. So, I'm going to get rid of the fraction. So, 298 times V2 equals 752 times 323. Now, those of you who know how to multiply by the inverse, what was it? 752 times 323?
Did I write it on?
I don't know, did we?
I got it.
I thought it was 752. Yeah, 752.
Yes.
All right, now that the fraction's gone, nobody in the room will solve it wrong. Okay, which is why I'm a fan of cross multiplying. So, all we have to do is divide by what?
298.
Now, if you want to solve it a different way, knock yourselves out. Okay? I hope not. I got 815.
That's what I got.
The units have to match, so it has to be milliliters. Yeah, it kind of does. Everybody feel okay about that?
Easy.
Yes? Can you try one? Can y'all try one?
Yes, ma'am.
Can I do one on the board?
Oh, write that down real quick. I stuck it in here because I always forget to teach it, so I just slapped it in somewhere weird. So write it down. A lot of times we use shorthand. Scientists are lazy. So instead of writing out numbers, we just stick in symbols like STP. STP stands for standard temperature and standard pressure. You know, I don't know why we can't just write the numbers instead of the letters, but we tend to write the letters. All right, so standard temperature is defined as 273 Kelvin. So anytime you read standard temperature, that means 273 Kelvin. You just put in that number. And if they say standard pressure is 1 atmosphere. Now, if they say STP, it means what?
Standard temperature. Oh, you just.
It means both of them. Okay? It means both of them if they give you STP. If they just say standard temperature, just 273K. And if it's standard pressure, it means just 1 atmosphere. Does everybody have it?
No.
How about now? All right. You don't have to write it. You've already done it. You got a sample. Just solve. Just solve.
Oh.
Be quick about it. We got 2 more laws to do in 25 minutes.
You gotta do it. It's okay.
All right, we done? All right, so what do we get? What's this? So V1 is 2.75. All right, T1 is,
293. No.
okay, so we changed it to 293K. And then V2 is,
2.46.
okay, and we're looking for T2, right? So we change colors. So we have 2.75 over 293 equals 2.46 over T2. So 2.75 T2 equals 293 times 2.46. We divide by 2.75 on both sides, and we get T2 equals what?
43.3.
You what?
I got 262.
Yeah, I got 262. Yeah, I got 262.
Yeah, I got 262.
Okay, I know what I did wrong.
Did you try to change it back?
No, for some reason I divided 293 and 246
Oh, okay.
instead of multiplying them.
Gotcha.
I was confused because I thought it was pretty low for Calvin.
Okay. Now, the reason that I wanted to work this out and talk about it is, did the question ask you for the temperature to be in Celsius? It just said find the temperature, right? So when you find it, leave it in what units? Leave it in kelvins, okay? The unit here is in what? So leave that unit in kelvins. The only time you want to change it back to Celsius is if they ask you for it in what? Celsius. Now, if the question says, what is the outside temperature in Celsius? Can you leave it in Celsius to calculate in Celsius?
Oh.
If the question says, what is the outside temperature in Celsius? You have to change it to kelvins, calculate in kelvins, and then what do you do with your answer? Subtract it and go back to Celsius. It has to be calculated in kelvins. The reason is, temperature is in the denominator. Two things Celsius can be is what kind of numbers?
Little.
What kind of numbers can Celsius be? Negative, which we don't want a negative volume. And what other number could be in the denominator if it's a Celsius number we can't have? Think math class. What number can we not have in the denominator that Celsius can be? I'll give you a hint. It's undefined. This is why I don't teach math.
0?
Yes. 0 Celsius cannot be in the denominator. So we change it to kelvins. Okay? All right. Gay-Lussac's law. Gay-Lussac, this is a man's name, not his sexual orientation, people. Pressure and temperature at constant volume. Now, this one is the law y'all are all familiar with, even though you don't know his name. It applies to like aerosol cans, tires, things of that nature. Not even going to draw a picture this time. If you heat a can.
Heat?
Heat.
Oh.
Heat. A can. Okay? What happens?
It explodes.
Yeah, well, we won't talk about it before it gets to that point. What happens to the
It
particles?
expands.
I'm asking you about the particles.
They move around.
They move faster, right? So if they move faster,
They touch each other more and they touch the container more. The same thing for all of them.
okay, they move faster, so they collide more often. Now, what's that translate into for us the last 2 days? If they collide more often, what's increasing?
Temperature and pressure.
There you go. Pressure's increasing.
I didn't mean temperature.
Okay, so if I said that we heat the can, what's that translate to? What am I doing to the temperature?
Raising it.
So temperature is increasing.
Oh,
Okay,
obviously.
pressure increases. So what's the relationship?
Directly proportional.
Okay, so this is why there are always warning signs on aerosol cans that say, don't heat it, don't let it exceed a certain temperature, because if you heat it, pressure is going to increase, and then what's going to happen then, Michaela?
Boom.
Correct, okay? It's got constant volume. Those sides don't give until it does what? Explodes. Same thing with tires. Tires, even though they're not as rigid as a can, they're not designed to exceed a certain pressure before they explode. All right, so.
So everything's directly proportional except for the first one.
Correct.
What was the
Pressure and Kelvin
oil?
temperature are directly proportional at constant volume, and moles. Pressure and Kelvin temperature are directly proportional at constant volume and moles. So again, because this one has temperature in it, it has Kelvin temperature. You cannot use Celsius.
For anything?
No, anytime you have Celsius, it has to be changed to Kelvin. You cannot use Celsius in any calculation. The only one that we will do all year, you remember Q, when we calculated Q equals mCp delta T, that one you can use Kelvin or Celsius. That's the only one. And the reason is because you're subtracting and only getting a difference. So it doesn't matter which temperature unit you use. Okay? All right, so the formula for this one is just like the last one because it's directly proportional. It's P1 over T1 equals P2 over T2. I think I actually feel some cool air. Y'all put a coat on. I cannot strip off something.
I mean,
It's fine.
Besides that, women's lectures room is open at 74. And on a day she's got 60-some people over there, she can't survive. Still says it's like 72 degrees in here. 71 points on.
That's a lot. I mean,
it's cold, yeah.
I can feel it drop, but
I don't know.
perfectly fine.
It feels
Alright. Write it. Let's see. Let me see what I can get rid of it for you.
So if they're directly proportional, you divide. Indirectly, you multiply. Okay.
Alright, I gotta make the sentence make sense.
Directions on the can caution the user to keep the can in a place where the temperature does not exceed
Alright, hold on.
52.
That one's less here. Less writing there. Do that one. I can't make that one make sense grammatically, so write that one. It's less writing.
Wow. Thank you.
You have an extra one in there?
So what?
You have an extra one in there?
No. All right. So if we look at the question, can you do it without me?
Yes.
Do it.
Anybody in here want to buy chicken?
I thought that was been due. What?
It's this Thursday though.
I know, I'm excited. I want some suckle.
Did you already buy them?
Yeah.
Ooh.
Mommy, I just picked up a paper. On his side. Figure my dad did. But I think you saw the different one. If they want to buy chicken. I'm trying to do it. But yeah, that's why you're hearing me. So when they're inversely proportional, multiply. When they're directly proportional, divide.
Right.
Okay.
All right. Can we look at what you came up with?
Yes. It was hard.
My brain shut off.
Can I do it on a board?
No, y'all just keep working. I'm just gonna write some stuff on the board. Did everybody get that far? Yes? Okay. Are we okay with that?
No.
Did I do it wrong?
You gotta subtract.
I'm not there yet.
Oh.
So I asked, are we okay with that? Yes? All right. So, since the question said find the new Celsius temperature, now we're going to take our Kelvin, okay, equals C plus 273. Our Kelvin's 309. And we'll subtract 273. So I get somewhere around 36 degrees Celsius. Questions? Feel okay about that? Yes, no? Yes?
Yes.
Yeah. Okay. So the last gas law is called the combined gas law. Okay? It combines exactly what you think. Boyles, Charles, and Gay-Lussac. Okay? It's V1, P1 over T1 equals V2, P2 over T2. Okay? It's the only one we've done today that's on the reference table. Okay? Charles, Boyles, and Gay-Lussac are not on the reference table. This one is. Okay? So write it down and I'm going to show you a neat trick.
Wait, what was the institute last week?
36.
36.
Oh, okay.
Is that his first and last name? Like, why is there a dash? Is that just his first name?
It's like anybody else's. It's hyphenated.
I've never read his name with a hyphenated first.
No, it's his last name. It's a hyphenated last
I
name.
can remember the rest. Oh, this is just their last name. How come it's not just his last name?
I don't know. Why does anybody have a hyphenated last name? Their parents combined
So
it.
that's his last name.
That's his
But
last name.
Oh.
Alright.
Like very.
So let's say that you have a moment on the quiz Friday and you're like, dang, I forgot the formula, but I know it's constant pressure, right? So this is the only formula that works this way, mind you. All right, but I know it's constant pressure. You can take P out and you're left with
Oh my.
Charles' law, but it's the one for without pressure. Okay? If you happen to forget that it has constant temperature, you can take temperature out and you have Boyles' law. Okay? It works the same for volume. All right? The combined gas law is the only one that works that way. And this formula is on your reference table. All right? I'll give you a moment to write that down, and then we're going to work it real quick. Now, the thing about the combined gas law is nothing is held constant. Okay? Nothing. So all of the units are there. Just write it down while I'm handing out homework. And everything has to match. Just like all of the other problems we've been working today, the units have to match. All right. All right, so when you look at this one, the only thing that makes this different is you have a triplet instead of a pair, okay? So you see how you have 50 liters, 25 at 25, and this 820? They all have to stay together. You can make them all the ones. You can make them all the twos. Again, because they're first, what do I tend to do with them? I make them the ones. So the 50 liters is a what? So I'm making it V1. 25 degrees Celsius is a what? Temperature. And then the 820 mmHg is a what? That's a pressure. All right, so when I keep going, it says what is the volume? So I'm solving for V2. I have to have T2, and I got to have P2. So T2 is what? Temperature 2 is the 10, and my pressure 2 is 650. Now, my units have to match, but again, temperature has to be in what? Temperature has to be in kelvins. So 25 plus 273 is 298 K, and 10 plus 273 is 283 K. Okay, my units here match. I'm good to go. Is everybody okay with how we identified what? Anybody lost by how I figured out anything? So the only thing I have left to do is what y'all laughed at a minute ago when I said we got to plug and chug.
Plug and chug.
So,
Don't forget to plug and chug, baby.
my formula is V1 P1 over T1 equals V2 P2 over T2. So 50 times 2 times 820 over 298 equals, I don't know V, 650 and over 283. Now again, if you have good math skills, you can do it any way you want. Ms. Wall only shows it with cross multiplication. Y'all are terrible with fractions. Let's get rid of the fraction. So 50 times 820 times cross multiply. So 283 equals, what goes to the other side? 298.
Times V times.
Yep. So I need V to be by itself. So I'm going to divide by 298 and 650. So V is by itself. So that means over here I'm dividing by 298 and by 650. And that's what gives me V. So that we have an answer, 50 times 820 times 283, divide 298, divide 650, I get 59.9. Here. 59.9, it has to be liters. All right, for homework, let's see which ones. We're only doing the ones on the front side that say problems, by the way. So we're staying on the front. It says problems. We're doing 3A and that's it.
Just 3A.
Yeah, just 3A. All right, and then we're jumping down to 5 and 6, and then do 10 and 11, and 14, 17, and 19.
Wait.
I'll take a picture of that so I can put it on the website. Your finger got caught putting up